that's today's topic. Not your father's Java, not your mother's JavaScript. It can be interchangeable. Whatever, we are going to talk about the past and maybe about some future. Well, why this topic? Because JavaScript is so popular on Java conferences, and it was hard to decide either to do a talk about Java or JavaScript, so I decided to bring some of my personal memories. So you can ask questions about my personal memories. That's the unique chance that you can get here. And my name is Dmitry Chuyko. I contribute to OpenJDK. I also participate in many conferences. Surprisingly, I've been writing a lot of code in Java, and then I appeared in a Java organization but in person, and then, well, now I worked at, that was in Oracle. Now I worked at a company named Bellsoft, and maybe if you know, Bellsoft releases its own distribution of OpenJDK called Liberica JDK, and also releases its own distribution of Linux called Alpaca, optimized for containers. We are not going to talk about that much today, so so you've been aware why I'm talking about Java at all, because, well, we participate in development of Java itself. So Java, is it so simple, right? What is the language that we use here for this example? Like, let's write a hello world. Maybe the colors are not so great, but we just have a main function, and we see out print a line, and then, well, some hello. Is it Java or not? Yes. No. It's not a real Java. Not the Java that I knew for many, many, many years. But probably it will become a Java of tomorrow. Not even today. Well, we'll see. So here's a source of truth, a book, right? So you know what? Java and JavaScript, they are somehow related. Well, both technologies are not too young. So it was 1995 then we saw both of them. And at that time, you maybe know that Java was mostly for Windows. Linux wasn't considered well, a serious alternative. So Windows was the major player. Also there was BSD and some Unix systems. But we already had accessible desktops. We had browsers. Well, and in that browser you could run your Java what? Yeah, your Java applets using some browser plugins. That sounds familiar. So you got some bytecode, you execute it. Well, secure applications in a sandbox with Java runtimes provided by Microsoft. Who remembers that? Well, at the same time, people decided to create a scripting language for browser pages. And eventually, that engine and that language was open sourced. And by the way, that gave a name to all the wide variety of technologies that we use. The name open source. Because before that, it used to be called free software. And free software is not something usable for large corporations to earn money, right? Because it's free. No one pays for it. But for open source, you can still develop open source and earn some money. And inside that well, nice area, there are cryptic acronyms like ECMA or TC39. So there's a standard for the language, which is actually not JavaScript. By the way, the trademark is owned by Oracle, right? Because it's like Java. So when it's ECMAScript, that's the name of the language, and there's a kind of standard, right? There's a some number, but which doesn't change. And also there's a committee that manages changes in that language called TC39, and you can go and actually, well, check the latest compatibility tables, what browsers support what features of the language, what version, and what particular parts of that version. And you even can run your newer JavaScript code on an older engines or in some compatibility mode to, you can compile it or transpile it to older versions, like use new features, newer features, and then get your also JavaScript code, but JavaScript of a lower version. But let's get back to Java. One of points where I started to work with Java were like, well, my colleague wrote a prototype, just a proxy server, a program that proxied some traffic, and it worked as a multi-threaded program. And the prototype was made in Java. And at that time, Java was, well, kind of still a new language. We studied it already, but for the real production, we used, well, more mature technologies like C++. So that task was to rewrite this prototype in C++. Well, in theory, I knew all that managed runtimes, but I was so impressed. The most complex part of it was to correctly release all the memory that you acquire in your multi-threaded environment. And that was C++ many years ago. It was even more complicated. So you immediately start getting all that strange synchronization errors or concurrency problems. You face some memory leaks. It's so complex. But Java solved it by design. You had an object-oriented language. Well, at least most of it, right? You had managed runtime with garbage collection, all that. And it's all strictly specified, which is great. And compatibility for that specification, it keeps going for many, many years, which again makes us happy with Java. But, well, at the same time, there's JavaScript. And it's a totally different idea from the very start. You don't have types. We just use objects. It's also simple. We don't know what exact fields exist in that objects. We can actually add them. And also everything is a function, so we can call things and we can convert strings and numbers. That's some kind of awful. And people even created talks dedicated to what you can get in some strange situations when you write cryptic JavaScript code. You can check some of these. But, well, it was very simple many years ago, right? Object has fields. This is still the basement. But at some point, the basement was all that we had. Well, at the same time, Java became an enterprise language from the very beginning. It could connect to database, in the Java ecosystem and the Java specs. It could send XML, the best language and the base language for all the times. Like, who uses Maven? Don't be shy, because it's based on the best language. It's based on XML. And who uses Gradle? Okay, 50-50. But it's based on JSON. And at that time, JSON didn't exist. But XML already existed. And it's a very, very suitable language for enterprise, right? Because it allows you to define any structure. It allows you to define schemas. It led us to use XML databases and write XML queries at that time. And we even used hardware accelerators for that XML databases. Crazy, right? We don't have these in the cloud right now, but at that time it was normal. You buy a special accelerator and you run your XML database on that. Well, Java also had great runtime features for inspecting your code its guts, like serialization, right? You could transmit bytecode over the wire, or you can transmit your data over the wire using standard means. Reflection, right? Again, to recreate or call stuff dynamically, but in a safe manner. And after a few years, just think about that, it got that debugging option. That's one of the things that we love Java for. We can easily debug it. We have so great debuggers and a standard interface, and all that works with compiled, JIT compiled code or interpreted code. We don't notice that. It's like it pretends to be stepping line by line. And you see that at the same time, JavaScript standard just developed slowly, new features, right? New objects, new standards. But finally, there were browsers that were able to run very much compatible JavaScript code. And from the very beginning, we could dynamically create or generate some JavaScript code and execute it at the same JavaScript context, like eval. Very unsafe, but very useful feature, right? And still, there are still JavaScript runtimes that don't support eval from the very beginning, because this is a powerful feature that requires you, well, thinking about how to implement it. Well, what happened when we started to work with Java? It was like, you can use all that collection libraries, you can use objects, but somehow everything just becomes an object, not a type thing, not an object of a particular type, right? No generics, but it's still very, very convenient, because you are so calm because you spend your time writing boilerplate. Typecasts, iterators, all that things. We don't write this code. Thank you, evolution. But even for the early versions of Java, parsers also exist. Because any language has its quirks, any language has its tricks, but the more sophisticated Java becomes, the more parsers we have nowadays. So no one really wants to write a code like this anymore. But that is how it started. And I started to work with Java 1.2, I think. Later, 1.4 was a great milestone, right? And other good specs appeared, like EGBs, right? I remember me poking around my university, looking at jobs available. Like people posted jobs on a wall. And one of popular topics was related to EGBs. And I just checked jobs on the wall in Dresden Technical University last week. And you know what? They are still around. So there are job offerings related to EGBs. So that's a great technology that we use since Java 1.4, right? But at the same time, Java started to compete and to provide real functions, like regular expression support, that haven't existed from the very start, but it exists from version 1. What it was, 3 maybe, not 6, right? What is it, 6? Yeah, that's 6, and that's Java E. Yeah, sorry. And I mentioned XML, which is essential, which is the very best markup language. And Java got support for, well, sophisticated XML features, better performance with XML, and we still use that. Well, JAX-P existed for many years as a part of core library. And also, the topic of performance became very hot. People needed to work with large amount of data, to access files in an effective manner. So that was solved. Then finally, all that boilerplate in a language started to reduce. Since Java 1.5, where we had generics and metadata, we got annotations, and later we got even type annotations where we can narrow down some type information. And that was very interesting, because I used to work in a project where we supported all that EGB stuff through metadata. So many different application servers required some properties to be set for different beans, and you could actually change that using a visual model and some property editors. Or you can change it in a code. But if you don't have annotations in your code, where do you put your metadata? Okay, you just write the same thing, but it's written in comments, right? Javadoc existed probably from the very beginning, and there was a thing called doclets. And you could generate even more metadata or real code using information from that doclets, and they could be tied with visual models and the code. After annotations, it became much more easier, but we supported both of them. That was for IDE that probably no one here remembers, that used to be called JBuilder. And yeah, the company that created this IDE is probably famous. It used to be called Borland. And if you know JetBrains IDEs, so many people from that time now work at and create different IDEs, but it's the same domain. Okay, I mentioned JSON and other things, but even before that, we started to use, well, asynchronous JavaScript and what? XML, right? Ajax. And we even started doing that before the name itself appeared. I'll probably tell the story a bit later. But you know, at the same time scale, in like Middle Ages, not the very ancient story, but Middle Ages, Spring Framework already existed. So we use a technology that is 20-year-old, which is still very modern, uses different languages, not just Java, right? You can use Kotlin or Groovy or whatever. And it successfully developed through times. So you know that XML, it's important, as we discussed. And you can actually use that special object, right? But it took some time to develop a standard for different browsers to have the same object, because well, there was some ActiveX components on Windows, different objects in different browsers, incompatibility. But finally, you can really you still can do things like it's written here, but it's not very convenient, right? You still have to build text or whatever if you use very, very oldish JavaScript. But who can help us here? Well, we'll see. Now, after solving some major complications, after being able to work with XML, well, both languages didn't develop that fast. But what developed are runtimes. Because again, the topic of performance is very important to conquer the market, conquer hearts. So in JavaScript, from the very beginning, there were multiple engines, but they were kind of primitive, right? And at some point, the company that decided to conquer the internet released its own browser, its own JavaScript engine, and started to say, okay, we have the fastest way to access the internet. We have the fastest engine, and this engine can even be used standalone as a backend processing thing. So V8 got multiple revisions of multiple implementations of its internals to provide effective just-in-time compilation, to provide all the optimizations. So it's a compiler problem. And you see that Node.js is here for more than 10 years, almost 15. But we were able to run JavaScript programs in Java. And it happened like since 2006. So GWT was a solution, again, developed mostly or entirely by Google, to use the same language for your backend and for your front end, right? Because it's typically a problem. How do you share your developers? How do you split the work? How do you, well, prognose your headcount or whatever? And it's still somehow alive, right? You can find a booth here with guys who still use that technology. Different things like web services were added in Java space, and also an engine to run JavaScript, a Java engine to run JavaScript, right? So since then, probably it became a big thing, so to combine Java and JavaScript, right? And we have it like for almost 20 years, 18 years. We could run a program in Java, run it in browser, or we could run a JavaScript program and invoke it and provide some Java objects and get a response back. And we even done so in the IDE space. Like we provided some JavaScript objects for scripting in projects on a large scale. Probably that doesn't happen now. I don't know. Anyone uses any automation for IDEs in their companies, like scripting across teams? Okay, no one. That was a weird idea, but it really worked for some complex and typical tasks. Anyway, at the same year, 2006, we saw jQuery. Actually, I haven't seen it. I saw it slightly later, but I was so impressed because previously we had to put all the JavaScript code in place. We had to tie to the actual structure of the document, and afterwards, well, we could separate the markup of the document, finally, the markup, and the code, the dynamic part. So that was a real start of Web 2.0, which is considered oldish nowadays, right? We like Web 3, I don't know. And this was so easy to use. And some magic happens behind the scenes. So it's a declarative style of programming. If you think about YAML files and Kubernetes, it's again the declarative style of getting things done. You just say, okay, arrange my deployment like this, and it magically happens. And the jQuery, you say, well, bind this logic like this, and it magically happens. So there's kind of runtime magic. So it was very convenient and modern at that time. And this library still powers like 70% of the internet. Maybe under the hood, maybe you even don't know if it's a dependency if you have a big web project. But the story of having all that dynamic features in Java, like providing objects to JavaScript and back, and the story of making it more safe and more performant, it developed logically. So in Java 7, we saw more concurrency updates, right? In Java, we can really create multi-threaded applications from the very start. In JavaScript, it's kind of a single-threaded thing. Naya developed. And Java 7 introduced invoke dynamic. That was a kind of a preparation, just an implementation of a thing that was used later. And it's widely used now. And a couple of years after that, well, guys in the domain of JavaScript realized that, well, we probably can help compilers a lot and have some heavy lifting very well optimized by our JavaScript compilers. And how you could do that in a language that is not typed? How you can make or create a hint to a compiler that your some object is actually an integer? Well, you can write an expression, a very localized one, that will help compiler to understand that your object or the result of the expression is always an integer. And after that, compiler can optimize the allocation of memory for that object and all the operations that it can participate in. Well, that was ugly, right? But this approach allowed to create faster JavaScript libraries. ASM.js wasn't so convenient. Well, why don't you provide just types for your objects, finally? Because we don't just write the code, we also read our code, and our colleagues read our code, or we read the code of past us. So help future me to read my code. So that's how TypeScript appeared. So you finally can put some real types, you will get type checks, and TypeScript is compiled into JavaScript by some JavaScript program. So it's a different language, and again, it's translated into something already supported by different browsers and engines, and you can use it. And at the same time, in Java 8, invoke dynamic was used to have, well, a different implementation of JavaScript engine called Nashorn. And that implementation was much more efficient than previous ones. So it even competed with native browser engines. That was an idea at that time, to bring developers using that popular languages, to bring all the libraries, all the ecosystem that already existed, because JavaScript became very, very popular. And still, well, we get questions about, well, how can we get Nashorn for later versions of Java? Well, and also you see concurrency side improved very dramatically in multiple Java versions, well, in 8 of course. And finally the language got lambdas, a feature from, well, other different languages, maybe not so popular as Java, but the feature is very convenient. You have anonymous functions, but it was hard to express what does it mean in that object-oriented language. And finally, JavaScript got way more performant engine in V8. The new code name was Turbofan, but anyway. And some constructs to write less boilerplate in your JavaScript code, or to make it stricter at the same time, because you can now understand what things you change and what things you don't change. And also some functionality that could be considered essential from the very beginning, like string templates, right? We get used to them in Python and other languages, but they didn't exist in JavaScript before 2015. And you see that even later than Java, JavaScript got lambda functions. They're called like arrow functions or whatever. But well, you have lambdas, you have, well, some nice templating things, regular expressions maybe. What about maps? Well, finally, after Java 8 has been released, JavaScript got standard maps in its kind of small standard library. It's really limited, but it looks essential. But why do we need maps in JavaScript anyway, right? We have objects, and we could put things right there in that objects. They are maps already. But besides of that, we now see classes in JavaScript. So you could not define a class before that. Now we can write kind of a class in JavaScript. Under the hood, it's still an object and a function, and there's a prototype, but we don't have that boilerplate. And we can create a constructor or declare a constructor and other stuff. And even some cool syntactical things, including trailing commas and including destructuring of some structures. Like here in this example, we can declare an object with some fields, and we can destructure it to fields and use that variables after destructuring. And that wasn't a JavaScript from the very beginning, right? And even more sophisticated examples with lists. Well, what finally happened during past at least 5 years or 8 years? We saw a newer TypeScript, so it survived and it continues to grow, and it gets some features that we are very familiar with as Java developers, like null safety, or Kotlin developers, null safety, or generics, right? If a language has types, then it probably needs some generics or type templating or whatever. And we saw finally Java version 9, which contained all that module system changed, but at the same time it contained great runtime, new great runtime features like var handles, for example. In JavaScript space, we saw a standard way of having your code prepared for optimization and being secure and being optimized and executed by a managed runtime, which is called WebAssembly. So just 5 years ago, JavaScript got its own bytecode. Something that Java had by design from the very beginning. So we now have bytecode for JavaScript. Well, not for JavaScript, for anything, right? Because we can implement a Java virtual machine that turns your Java programs or your Kotlin programs into the bytecode that is executed by that WASM runtimes. And there are multiple examples of such machines. Like here's like TVM and other stuff. So you can turn your JavaScript into Java bytecode and vice versa. That's funny. I'm not sure how deep you can get while doing that, but it's a good exercise. And after that, you noticed that few years before JavaScript was simplified or enhanced by that var and lat constants. And the same that's what we saw in Java 10 and later in Java 11. We now can omit or may omit some types because they are inferred. So it's still a strictly typed language, I mean Java, but compiler helps us. Compiler knows the exact types in certain points in your program, so it's easy. Well, and Java is also for the internet. So it started to support TLS. It finally got a standard HTTP client, right? Unlike many other languages that had it for multiple years, Java didn't have one. Because why do you need an HTTP client if you use Corba, right? That's a real business technology. And finally, people stopped to use Corba, and Java dropped Corba. And you see, as I mentioned, even on this part of the timeline, we see 2 versions of TypeScript, which develops, and at the same time, releases of the ECMAScript specification became yearly. So we now have a clear update every year. And since then we got promises, right? We don't have a multi-threaded execution, but there are promises in JavaScript, just like completable futures that are actually like promises in other languages. And finally, regular expression support. So you could probably think about replacing your PHP, or what's the best language for regular expression processing? Okay, yeah, that works, but in production, Perl, yeah. So we can finally think about replacing Perl with JavaScript. Well, a thing that I mentioned, threading commas, right? We don't exist in vacuum. People do distributed shared code reviews. We now use GitHub. And what if someone changes some list, and this list ends with just some parentheses or whatever? So we need probably, in many cases, to change 2 lines of code, right? Because we need to put to remove a comma or to put an additional comma, and that's bothering. So you can leave a comma in the end of the list. I think that's one of greatly debated features of a future Java, right? And now, I mentioned that different engines to execute JavaScript, and they were removed from the core JDK. But at the same time, we now have an option to bind our Java, JavaScript, and other languages using GraalVM, using Truffle, a framework to create effective JIT compilation, to provide effective JIT compilation for different languages. You just need to describe the language to kind of create an interpreter, and it will be optimized to run, and even can be used in native images. And now it also supports WASM. So you can create that bytecode from JavaScript or from whatever you like and execute it in GraalVM. And you see there's a certain language support level. Like it can be, well, ECMAScript 6 or newer languages. And again, there's a timeline of standard being enhanced, and there's a timeline of actual implementations. And the actual implementations are slightly behind, of course. And you see what happens in Java now. There are multiple previews of different features. So there are preview features, there are now incubated APIs. So this is a way to deliver early previews of different runtime and language features to users. And things like text blocks and switch expressions, well, they went through multiple previews, and we finally got them in later versions. And also that language changes are now splitted by parts. So you can notice that release schedule, it's not even yearly. We have 2 releases a year for Java, and every release got some new features, and they can be in preview or in an incubator, or they finally can be released. And you see what happened with JavaScript after it got finally support for maps. It also got support for big integers, like financial applications written in JavaScript. Think about that. Or maybe spaceships with JavaScript on board. Well, we actually saw that last year. We saw a spaceship with some classical controls, but actually showing some nice UI written in JavaScript. Yeah, SpaceX. And again, we remember about Kotlin and how null safety helps people. So that's what also happens in JavaScript. We can now use some features related to the problem, at least. Well, I already mentioned that GraalVM implementation, and we also like to support that. And by the way, we just recently implemented a parallel GC for GraalVM, so we can use another garbage collector besides of like serial or epsilon. Yeah. So that polyglot feature requires much less ceremony than it used to be for Nashorn, for example. So the same thing wouldn't fit if I would write it for Nashorn, because it required much more actions related to the context. Here it's easy. We just call some functionality from our JavaScript thing, and we can also pass the data and access the data inside our different language contexts. What's interesting about that some things are restricted, like you can't operate with file system, for example, or other I/O. It's only targeted to using some calculation libraries or generation libraries, like you can generate an image, for example, a plot of some function. Because different languages like R or JavaScript has great libraries that sometimes even Java ecosystem doesn't have. So that's the interoperability here. And finally, we got our, well, the most recent LTS version of Java, Java 17, but it's not the last version, of course, even not the current version. And you already saw one of the features that I mentioned is switch and pattern matching for switch, and we finally have it in Java. There are multiple jobs, and we have records, because objects are too complex sometimes. We don't want to write that equals hash code. We don't want to write all the assignments in constructors. We don't want to have that getters and setters. That's crazy, right? We just need simple objects. In many cases, even in serious programs that are business related. And the type system of Java becomes more complicated with that changes, because we are about to have, well, value types, records, classes, and now sealed classes where we can permit certain structures. At the same time, a slightly more complex type system, when we declare all the types, allows us to have strictly type-checked programs with much less boilerplate. Like you know the examples of switch expressions and sealed classes, for example. That allows you to omit certain like default cases in switch to get rid of that unknown behavior, unknown cases, etc. And you see that runtime for JavaScript at the same time supports something we are very familiar with, well, in Java for many years, like quick references or finalizers. So Java is getting rid of finalization, and JavaScript is finally getting some kind of finalization. Maybe in another 10 years it will be, I don't know, removed. And I mentioned completable futures and promises, and again, we see some parity finally in Java and JavaScript, at least in some essential methods. So other notable features are destructuring records, for example. I'll show you a very short example later. Or in JavaScript, there is now async, right, or await. Not really async, but we can much easier declare that futures and use them, just like probably in coroutines. And in Java, we now have, well, virtual threads. Easy. So Previously, we saw that JavaScript had classes, so classes typically have their fields. What about modifiers and different access rules? Just like I described what was done for metadata and EGB management for Java, there used to be some frameworks to check your access rules for JavaScript code. And now it's official. You can create modifiers for your fields, besides of constructors, besides of class definitions. You can create private fields in your JavaScript program. Nothing was private in JavaScript before that. All was public. Well. So finally we are getting back to the very beginning. We will have that records destructuring, that's an example. Just like in JavaScript, we can, well, match a certain structure and refer parts of that structure. We can create much shorter switch cases to get rid of that boilerplate. We previously got rid of that exception handling ceremony with by using try the resources. Now much less boilerplate with finally strings and types in switch clauses. And default classes will allow us to run that program that I've shown you in the very beginning. And also, to run the program, you don't need to invoke the Java compiler, the JavaC, because you can take your program written in Java, just like in many other languages, and say, Java, please run me a Java program. And it finally works. And here, under the hood, there is some class, of course. And this there's some instance of this class, because this method is not static, right? So it's kind of an agreement about defaults, just like in Spring Framework. There are good defaults that you can use. So that's the Java of tomorrow. Let's wait for trailing commas support. Yeah, thank you. All right, let's see if you have some questions. As I mentioned, that's the story about what I've been involved. So you can ask about that. All right, then you can find me on the booth. We have a booth here. Me and my colleagues would be happy to answer interesting questions and to show you some optimizations for your Spring Boot containers or whatever. Thank you for your attention.